Solving problems with more than one right triangle. So sometimes you'll have a problem and there's two triangles in the picture and you're going to have to solve for a certain thing, and you might have to do different steps to solve for one triangle. So for this one we want to find BC. So let's call that X. So in order to find BC, we need to know a length from this triangle. So we either need DC or BD. And because we know this angle and this hypotenuse, we are easily able to solve for BD. So BD, let's call that Y, is our opposite, and 22.9 is our hypotenuse. So we have an O and an H, so we're going to use the sine ratio. So sine of 26 is equal to Y over 22.9. Multiply both sides by 22.9, and you get 22.9 sine of 26 degrees equals Y. We should get to one decimal place 10.0. So BD, let's do a different color, is 10. Now that we know 10, that's still our opposite side from 49. And we want to find the hypotenuse. So we have an O and an H again, so we're going to use sine. So sine of 49 degrees is equal to opposite, which is 10, over hypotenuse, which is our X. X is the one on the bottom, so we're going to flip them around. So 10 divided by sine of 49. Type that into your calculator, and you should get 13.3 centimeters. So BC is 13.3 centimeters. Jason is lying on the ground halfway between two trees that are 100 meters apart. The angle of elevation to the tops of the trees are 13 and 18 degrees. How much taller is one tree than the other? So he's lying midway, so halfway. So that means from here to here it's 50, and from here to here it's 50. So we want to find X and Y, the two different trees. So from this triangle, X is our opposite, and we know our adjacent. So we're going to use, we have O and A, we're going to do tangent. So tan of, this is M, which is 13 degrees, is equal to opposite, which is X, over adjacent, which is 50. We're going to multiply both sides by 50, so 50 tan 13 is equal to X, and X should be 11.5. The second tree, we have our opposite and our adjacent again. So O and A, we're going to use tangent. So tan of 18 degrees is equal to Y over 850. So same thing, but a different angle this time. So 50 tan 18 is equal to Y. And if you type that into your calculator, you should get 16.2. Now we want to know the difference between the two, so we're going to subtract them. So 16.2 subtract 11.5 is 4.7. So tree 2 is 4.7 meters taller than tree 1. For a small plane, V, the angle of depression of a sailboat is 21 degrees. So that's this way. And the angle of depression to a ferry is 52 degrees. So we want to find how far the boats are away if the plane is 1650 meters above the ground. So we want to find this total distance. So first thing we're going to do is, if you notice right here, we have a 90-degree angle. So that means that if you take the angle here, so of 21, and you find the angle of V right here, it'll equal 90 degrees. So to find that angle, we go 90 minus 21, and then we should get 69 degrees. So inside this triangle, this angle is 69 degrees. We can do the same thing on the other side. So 90 minus 52 is equal to 38 degrees. So we're going to put those in right now. Now we want to find UX and XW and add them together. So from our angle 69, we have an opposite side and an adjacent side. Now because we have A and an O, we're going to do tangent. So tan of 69 degrees is equal to opposite, which is X, over adjacent, which is 1650. And we're going to multiply both sides by 1650. So 1650 tan 69 is equal to X. And we should get 4,298. So that is UX. Now we're going to do the same thing from 38. So we have an opposite and an adjacent. So we're going to do tangent. So tan of 38 is equal to opposite, which is Y, over adjacent, which is 1650. Multiply both sides by 1650, and we get 1650 tan 38. Type that into your calculator, and you should get 1289. So XW equals 1289. So we want to find the total distance between the two, so we're going to do UX plus XW, which is 4,298 plus 1,289, which is 5,587. So that is how far apart the sailboat and the ferry are actually. Okay, a surveyor stands at the window on the 9th floor of an office tower. He measures the angles of elevation and depression. So he's standing right here, and he measures up and down. The surveyor sketches the plan and his measurements. Determine the height of the taller building. So we want to find the tallest building. So there's a drawing in your book. I want you to redraw it down below because it's kind of dark and it's easier for us to write in on our own drawings. So you don't need this triangle. It should look like this. Now we have three different right triangles. And I want you to label it A, B, C, D, E. So our first step is to notice that we have a 90-degree angle right here. So one angle B will be equal to 90 minus 42, which is 48 degrees. From this, we can find the distance between the two buildings. We're going to need that length, or we can find the hypotenuse, which is the diagonal between the two buildings. So either length would be helpful to solving for the height of the building, but because this hypotenuse is part of the second triangle, we need to find that. So we need to find BC. So that's our second step. So we know the adjacent side and the hypotenuse. So we know an A and an H, so we're going to use cos. So cos of 48 is equal to adjacent, which is 39, over x. Because x is on the bottom, we're going to flip. So x is equal to 39 divided by cos of 48. Type that into your calculator and you should get BC, which is our x, to be 58.3. So this length is 58.3. Our next step is we can do two different things. We're going to need both this side and this side. So let's start with DC. So from 42, that is our opposite side. We know our hypotenuse, so we're going to use sine. So sine of 42 is equal to opposite, which is, let's call this y. Y over hypotenuse, which is 58.3. We're going to multiply both sides by 58.3. So 58.3 sine of 42 is equal to y. Type that into your calculator and you should get 43.3 to be y. So right here is 43.3. Let me just erase this. Now we know half the building size, so we need to find that other half. So we're going to find this side now. So that is our adjacent side from angle 42. So we know the adjacent and the hypotenuse. So we're going to use cos. So cos of 42 is equal to adjacent, which is our unknown, over hypotenuse, which is 58.3. Multiply each side by 58.3 and type it into your calculator. So 58.3 cos 42, and you should get 43.3. And I wrote the wrong number down. This one's 39. So go back, change that. This should be a 39. I just wrote the wrong number. So this number is 43.3. Now we have only one side left to find, and that is our z. So that is opposite of our angle, and we know the adjacent, so we're going to do tangent. So tan of 31 is equal to opposite, which is z, divided by adjacent, which is 43.3. Multiply both sides by 43.3, so 43.3 tan of 31 equals z, and you should get 26. So now we know both sections of the building, so we're going to add together ED plus DC, so 26 plus 39, which is 65 meters. So the building is 65 meters high.